second last session, session 7. This will be like I said, second last session, but the last session of new content that we're going to cover. Yeah. Before we get started, we have our pre-session questions. If you guys don't mind heading over to Top Hat, that would be awesome. I think we just have one question, but yeah. If you guys want to head over to Top Hat, that question is open. Just asking you guys how last week's session exercises went. Is there any concerns with last week's session or last week's assignment? Sorry. Did you guys find anything particularly hard, particularly easy, anything like that? How did you guys feel it went? Pretty good? Good. If you're just coming in now, we're just on Top Hat doing our pre-session quiz. I noticed a few people just still trickling in. Last 10 seconds here. All right. Let's see what you guys said. So for Pythonic Lava, everyone said it was great. It's good to hear. Bugbusters was a little difficult. We're great. Good to hear. Okay, sweet. Okay, let's get started for today. So, just a disclaimer before we start this. There's going to be some links to a file that we're going to need later in today's session. It's called collision.py. And also for some images, just keep that in mind if you guys have the notes open. Those links will be in the speaker notes. Yeah, we'll get into those files later. Don't worry what they are right now. I'll explain what they are. Quick overview for today. Another application of software engineering, which is smelling out diseases. And then the main focus today is going to be collisions and using images in our games. Okay. These are going to be important for you guys' the final project that you guys are going to be able to do at the end of the session, basically. So yeah. So how good is computer's nose? So numerous studies have shown that some dogs can detect diseases by smell, right? So and sometimes they're up to 99% accurate. Now there's been some researchers at MRT that are working on a way in automating the smelling capabilities of a canine nose using machine learning process. They've come up with a system that can detect chemical and microbial content of air samples with a greater sensitivity than a dog's nose. Okay. And again, another application of software engineering, programming, all can be all concepts that they use in there are built off what we learn in this course, right? Quick functions review. So real quickly in the chat too, can you guys just tell me how you guys are feeling with functions? I think for the most part, you guys are feeling pretty good with them. Is there any quick questions that we have about functions? If you have some, now would be the time to ask them, because I can cover it quickly. If not, I'll just continue with the review. But just remember that this is the basic syntax for creating a function, right? You need the def keyword, then you have the name of your function, and then you have the parameters, the function body, and then a return value. Remember too that for functions, the what's it called? The body, sorry, the function name and the body are required. The parameters and return value are not. Those are optional, right? And then just to call the function, right, you just call the name of your function with those two curved brackets and any parameters if you have any, right? Some for like, remember we talked about again arguments or parameters, right? So like the ellipse takes in multiple parameters. You can store results of the functions in variables if they return something, right? Remember, it has to return something for you to store the value or the function call, right? So 2 plus 2, if it returns the value of 2 plus 2, this is how you get that value from that function, right? From what I see in the chat, sounds like you guys like them. That's good. I love functions too. They make my life a lot easier and make your code more easy to read, right? Collisions. So this is what we're going to be talking about for most of the session today. So what are collisions? So collisions are just a word for when a moving object makes contact with another. Okay, we've dealt with very simple examples of collisions in some of our exercises. I know some of our what's it called? Some of our assignments and exercises have dealt with, hey, if like this object hits this or it gets to the edge of the window, we've dealt with that. So we're going to be building a little bit more on it. So how do they work? So to detect the collisions, we'll be using what's called bounding box. Okay, bounding box represents the edges of a shape that we are drawing. So if we have a rectangle here, right, the bounding box of the rectangle is this dashed green line. Okay, it's basically just defines an outer layer that says these are the edges of an object. This is like the space that an object occupies, is one way to think to put it. When the bounding box of two shapes overlap, we know a collision has occurred, right? So you guys can see here that we have two rectangles, 1 and 2. Obviously, they're not colliding, they're not touching, but once they overlap, we know we've had some type of collision occur, right? Can you guys... I just see someone in the chat saying that they can't hear me. You guys can okay. Can you guys hear me or no? Can you guys just tell me quick, just so I can check? You guys can? Okay. So defining our bounding box is very similar to the rectangle function that we've been using, where it takes in x, a y coordinate, and then our width and our height values. And it works just like a rectangle in the sense that the coordinate for the x and the y is in the top left corner. Okay. So to create our bounding box, we need to use the bounding box function. So the bounding box function actually returns a value. Okay, and we'll talk a little bit about that later. But again, it's very similar to an x to a rectangle, where you take in your x, your y position, your width, and your height, right? And like, just again, like another note, it's the exact same as rectangle function. We'll talk about this return value here in the next slide. So we can store the return value of a bounding box in a variable. This variable contains the position and the dimensions of that bounding box. Okay, so you guys will see later, but it pretty much just it stores the values, those values, into a variable that make it very easy to check whether or not that object has collided with another object, and we'll talk about that later, right? So so like I said, now we can check if two bounding boxes have collided using a new function called collided, right? So collided takes in two bounding box objects, okay? And it checks if they have at any point collided. I believe it returns a Boolean value, right? So yeah, it does here, right? So you can see here that if we have rectangle 1, rectangle 2, each with their bounding box, which is that green dashed line, okay? If at this point, if we ran this code, collided bounds 1 and bounds 2, right? We would get a return value of false, okay? Because they're not overlapping, therefore they're not colliding at any point, okay? But if they were to collide, then the collided function will return true. Okay, it's just how that's just a brief example of how collided works with bound boxes. Okay, so this brings us to our first question. So which of the following statements are true for this collision? I believe the statements are in the top hat question. Let me just double check. Yes. So if you guys, I'll leave this up for you guys, but the statements that you're checking for whether or not they're true are in the top hat question. So I'll just start that now. And you guys are free to answer that. Go ahead. We have about 45 seconds left, guys. Still looks like a few of you haven't answered yet. Last 10 seconds. If you guys haven't put in an answer yet, just select one, or you got 25% of a chance to get the right answer. Okay. So let's look at what you guys answered. So, oh geez, everyone got the right answer. Good to see. So yeah, C is the right answer, right? If we look at the bounds box here, right, or at the options here, right? Bounds 1 will be true. Bounds 2 will be true. Those don't return Boolean values, so technically they won't be true. Um, that just eliminates D for us as well. And we can see too that in this image here that the two boxes are overlapping. So therefore that if we called a collided function for bounds 1 and 2, that would be true. Right? You guys got that pretty good. So that was good to see. Alrighty, let's move on. So how do we use collided, right? Like what's the actual syntax for collided? So you guys remember that bounding box returns a value, okay? And we can set that value to a variable. So we're doing that here in this first snippet, right? So we create two bounding boxes and we set that bounding box return value to bounds 1 and bounds 2, okay? Then we want to check if the boxes have collided. Okay, so if collided, that works fine because if the boxes haven't collided, this will be if false and this code won't run. If collided is true between bounds 1 and bounds 2, then this statement will be true and we'll run the code underneath. Okay. Can anyone think where you might want to put this kind of statement? What function you would want to check if two boxes have collided? Does any would you want to do in def setup or def draw? Which function would you guys want to use or put this statement in? Can you guys just put it in the chat? Right. So the people who have answered would have got it right. You'd want to put this kind of if statement inside your draw function, because if you have moving shapes in your program, remember how draw works, it loops consistently. So if you want to, like, if you have objects moving, right, you need to constantly be checking if two objects have collided, right? The only way to do that is to constantly run the if statement to check if two objects have collided. And the only way to really do that is to put it in your draw function. Okay. One thing to keep in mind, I've noticed that sometimes when we introduce new concepts, sometimes you guys are putting the functions in the wrong place and then having trouble getting the results that you guys need. So this is just one thing to think about when you guys start creating your final projects or doing any further exercises that we have in the sessions. Okay. So how do we actually use collide? How do we use the function? How do we get access to the function? So we're going to go over this today. So remember at the beginning of the session, I mentioned speaker notes. So this is where if you guys have access to the slides, you guys might need to check. I believe it's this slide. Yes, it's here. Yeah. So if you guys go to slide 20 in these slides and you scroll up, there's this code here. Okay. You need to just copy and paste this into a file. I'll show you guys how to do it here in a sec. I'll just go over the steps here and then I'll actually do them. So in order to implement the collided code or the collided function, we need to import its code from a file called collision. So what you're going to do on Trinket is you're going to actually create a new file. Okay. Then you're going to name the file collisions.py and copy the code, copy and paste the code. What's it called? From the speaker notes into that file. Okay. Be very careful how you spell collisions. Okay. Because you need to have it spelled correctly, right? Remember, it's case sensitive. Okay. Or else it will not work. Okay. Then in whichever code that you're running, so say like in your main, you need to have from collisions import star. Okay. So I'll just show you guys this quickly. So you're going to go here. You're going to take this code. I'll put this code here too in the chat just in case. Oh, it's not letting me. Okay. Let me see if I can do this in pieces then. So that's one piece. That's another piece. And there's another. I would highly recommend that you guys go through the speaker notes to grab this. If you don't have access to the slides right now, that's okay. You can do it through that as well. But if we head over to Trinket, I've kind of already done it here, guys. But I've created a new file. I'll just delete this and do it again. So we're going to call it, oh, no, collisions.py. I spelled that right? Get this here. You need a .py or else Trinket's not going to recognize it as a Python file. So you can do that and then go back to the speaker notes here. Ooh. I need to take this code, Control C, okay, put it in like that. It should save automatically. And then if we go to this code here, it's for a later example. If we go from oops, sorry. Okay, we should be able to run this, get no errors. If I change this, say I spell it correctly, it'll show up as an error. So if you can do from processing import star and then from collision import star and you don't get any errors, you've done it correctly. Okay. Does that make sense? Did anyone have trouble with that? If you guys do, we can cover in the breakout rooms. It's very simple to fix. Okay. Most of the time it's just a syntax error. But yeah. So let's continue on. So here's an example, right? This is some sample code of how you might use the collision library and how you might use the collide function again. Okay. So if we have our two boxes, right? Bounds for 1 and for 2. Okay. We're going to check if these two objects have collided. If they have collided, then we're going to change the direction in which they're moving. Okay, so right now they're moving toward each other, and then if they collide, we're going to invert the speed variable that we have so that it changes the direction of which the boxes are moving, right? And we do that just by multiplying it by -1. Okay, then we continuously add that value to our x position, the speed value that we assigned here. Okay, and then we just for some color and color, and this is just giving us the color for each rectangle, and then this code will loop again. This would all be inside of our draw function. All right, and I believe, oh yeah, so this is just what's really happening inside the collided function. So let's take a look at like box 1 and box 2. Okay, so they each have their left and their right side. Okay, so box 1 has L1 and R1, box 2 has L2 and R2. Okay, so if L1 is greater than R2, okay, so if this is farther, or sorry, is less than R2, so L1 is to the left of R2, and, okay, not or, and the left side of this rectangle is less than the right side of R1. Okay, so L2 is less than R1. The actual x coordinates, the x values of these points are, if L2 is less than R1, then we know we have a collision, right? We know that they're overlapping. Okay, it's a very specific case, right, that checks for overlapping, right? If we look at the bottom here, right, we can see that L1 is less than R2, right? Or L1 is not less than R2, right? So that there's no collision, right? Because what's it called? You might have, say, like you can still see here that L2 is less than R1, right? Because the second box is left of the first box, right? But we see that these values here, L1 is not less than R2, so we can tell that they're not overlapping. Okay, this is just for your guys' knowledge, just to keep in mind on how the collided function works. Okay, we're not going to be asking you guys to program this or anything like that. Okay, and then it works the same way vertically. So you have top 1, bottom 1, top 2, bottom 2, right? This just checks again if top 1 is less than bottom 2, and if top 2 is less than bottom 1, which it's not in this case, then we don't have a collision. Okay, vice versa. If top 1 is less than bottom 2, okay, and top 2 is less than bottom 1, okay, we have a collision, right? Because basically we can tell by this statement that top 2 is in between top 1 and bottom 1, right? And in that case, we would have a collision. Okay, another note too, that I know how we talked about in this example that we're looking at the x's, right? And in this case, we're only looking at the y coordinates of the bounds box, but both the x and the y will be checked simultaneously, right? Because there could be examples like if we were checking, say, only tops, but this box was to the right, right? This statement would still run true, but they technically would be overlapping. So we have to check both the x and the y at the same time to make sure that two objects have fully collided. So this actually brings us to our first exercise. So we only have one exercise today. So we might set aside 20 minutes for this. We'll see how well it goes. Okay, but we want you guys to create a rectangle that follows your mouse, okay, along your screen, okay? We also want you to create a target that moves from side to side, that little blue square, okay? It's just going to bounce side to side. We want you guys to use collisions to check if the rectangles are overlapping when the mouse is pressed, okay? And just display some text if they are, okay? That's all you guys have to do. These are just some questions to ask you guys, for you guys to ask yourself as you're going through the exercise, right? So can you make the blue square bounce back when touching the left and right edges, right? That's one thing you can do. You can use the same logic as the previous example, okay? Where you have bounce 1 and bounce 2, right? Or two different types, or the bounds for each of the boxes, okay? And then you can have your if collided statement that checks if those two objects have collided, okay? And then also ask yourself, what are the two bounds that we're using in this object? What are the two boundaries that we need to, or the two bounding boxes that we need to have in this assignment? So we'll go into our breakout rooms now. I'll give you guys 20 minutes to do this one. This is the only one we have today. And then we'll take it from there. All right. How did you guys find that assignment or that exercise? Hard, easy, in between, easy. Did anyone not finish? Did everyone finish? What's the consensus here, guys? Just so I can get an idea before I haven't finished, hard, didn't finish, almost finished. Okay. Good to hear that it was a nice activity. Hard, yeah. Okay, so we'll go over a solution here. We'll go in a little bit more in depth. If you guys have questions, like please ask them. Okay, because I want to make sure you guys understand this. This is like super important for your guys' final projects if you choose to do them. Okay, so let's dive in. So very important, right? You need to have this collision code in here. Okay. I'm assuming all of you guys got that. Did anyone have trouble getting this started? Like inputting the collision code, making sure it was right? No. I hope I figure it might have been easier, but I've also seen people have some trouble with it. So I would be surprised if you guys did. That's okay. But we need that from collision import star, which just means import everything from that collision file. The way we did our solution was we initialized some values here, our target X, our target Y, and our target speed. Okay, so those are used for the bounce for the rectangle that's bouncing side to side. Okay, our setup function, nothing new there. And then our draw function. So we globalize that target X, target Y, and speed. Okay, we have to call our background function because we don't want to repeatedly show every rectangle that we draw. Okay, so this is the drawing the target code. So we just fill it with a specific color. I think for the solution we don't have it blue, we just have it empty. Then we just define a rectangle, and then this is the logic that checks for if the target has reached one of the sides. So if because remember of how the X and Y coordinate work with the rectangle, right? We had to just add a little bit just to make sure that it looks nice. So we added 20 because that is the width and height. So we're just checking here again if it hits the sides. If it does, we just invert the value of the speed by multiplying it by -1. Just changes the direction. Okay. And then we just set target X and we add the target speed to it. Okay. And then we create our target bounds using that bounding box function with the same target X and target Y that we're using to create that rectangle, the original target itself. Okay. Now this is drawing the rectangle that we use. This is kind of like our reticle, that one that follows your mouse to check for the square. Okay, so this is just some basic color options. This is creating the rectangle. Okay, there's a -15 in here, right? Because like we've seen before, the rectangle X and Y are in the top left corner. So if you want your mouse to be in the center of that rectangle, you just need to set the coordinate of that rectangle to half your width, half your width and height, and minus it from minus that value from the mouse X, mouse Y. Okay, or otherwise your cursor is going to be in the top left corner of your rectangle. Okay, And then we set a bounding box to the mouse X and mouse Y. Okay. And then this is the collision logic. Okay. So this is what we've covered in the first half of this session comes into play. So again, we're just doing the if collided. Okay. That's all you guys need to do to check if two things have collided. And then the target bounds and the player bounds. Okay. So the target bounds is the one that bounces side to side. Okay. And the player bounds is the bounds of the rectangle that follows your cursor. Okay. So we're checking if collided is true and, right? So and mouse is pressed, right? If those two things are true, okay, we're going to just display the text saying that you got it. Okay. You could too also have if collided and then have another if statement here that says if pressed. Okay. Then you could have the same logic here underneath that. This just does 2 and 1. Okay. So either or would have worked. If we run this code, okay. If it lets me run this code, just copy and paste this and throw it in main. Okay, we run this. Oh, collisions. We run that. Okay, you can see here that this rectangle follows my cursor, and anytime I'm just holding down the mouse button, it's pressed, right? So I can try and follow it, and it works. Okay. Does anyone have any questions with this assignment? Because I know some of you guys said you didn't finish. I don't know if it was because you guys weren't sure or whatever. We have time, guys. Ask me questions. Try and answer them as best I can. You guys want to look at the code here? Yep, I can do that. There might be a small formatting issue just because of the way Zoom text chat works, but yeah. Pretty much everything that we've done in this, everything in this draw function, aside from the collision logic and the player bounds and the target bounds, we've done, right? This is stuff that we've seen before. You just need to know that if you want to keep track of an object's, like if you want to create those bounding objects to use that collision function, you need to also create a bounding box for every object you create, right? So if I didn't create this target bounds, it wouldn't be working properly. You need to have a bounding box, and then you're just passing those two objects, right? Because we're setting target bounds equal to the return value of these two bounding boxes, right? Here. And then we're just putting those in the collider function and it does it all for us. Okay. Any other questions? I think there is a question, but I think Devin answered. Is there a limit to how many imports we can use? No, you can import as much as you want. Okay. Any other questions before I move on? We will later. Don't worry about it right now. I'm just putting ideas in your guys' head as we go along so you guys can think about things. But the final project, I believe we're asking you guys to create your own game. You guys will see examples at the end of the session too of previous year submissions to give you guys some ideas. Okay. So speaking of which, let's continue on. If there's no other questions, is there any more, guys? You guys are good? Okay. Let's move on to images. Okay. So we can also import images into our games. We can use images for backgrounds, for characters, pretty much anything we want to use, right? So uploading images. So Trinket comes with images that you guys can use. We will also provide you guys with some that you guys want. You guys can also search for some. I'll go over each of them so you guys know what to do. But to upload images, okay, you're going to look for this icon in your Trinket, in Trinket, okay? And then, then you're going to click upload a new image and add your image and press done, okay? So you can find images online, okay? there's some that we provide for you guys. There's a link to a Google Doc folder, I believe, that has a bunch of images. I'll go through an example just to show you guys. But just a quick note, transparent PNG files work best. So I'll show you guys what that looks like here after I go over the code example. So in order to use an image, we have to load the image as a variable using the load image function. Okay, so if you wanted to say we have an image file called ship.png, okay, we call this load image, okay, and we just put in the name of the file in a string format. Okay, so you need the single or double quotes here, the name of the picture file, okay, and then you just call that inside load image, and then ship will just be that image. Okay, if you actually want to put that image onto your screen, okay, you just need to call the image function, the image object that you created when you called load image. Okay, you could also put just load image here, but sometimes if you need to, right, sometimes it's better to put in a variable. Then the X, the Y, and then the width and height of the image that you want to use. Okay. These are just some values, right? This is just going over the image function, right? So the image function, obviously that's the name, right? The name of the image, which in the previous example was called ship. Okay. The X, the Y coordinate, the width, and the height. Okay. So here's one example, right, of some sample code, right, that you could use. So for example, you have your setup, you define some variables to be global, which were background and ship. You set background to an image of background.png. Okay, same sort of deal with ship. You create your size. You grab those functions again inside of your draw function. And then these are actually displaying the image. This is where you're displaying the image using the image function. So image background, it's going to put in the top left corner, but it's going to be the whole size of the screen, right? Because that's our background. So we create that image. And then the image for the ship follows our cursor, and we're putting it at the center of the image, or the cursor at the center of our image. So that's why we have that little arithmetic there. Okay. So also on this slide, this is where we have, if you want to use those two specific images, these are download links. If we go to, I believe, yes. So if you go to slide 29, we have a whole Google Drive of images that you guys can use. And this is where I'll show you guys the example. So let's say we go to, this is the Google Drive that you guys all have access to. It's in the speaker notes. Okay. And let's say I wanted to import a player object. Okay. So let's grab, say, this bird one, for example, or what else do we have here? Let's grab this one. Okay. So if we download this image, okay, we just download it to our computer here. If we go into Trinket, okay, first thing we need to do is add the image to our library. So if we click add image, okay, and click add image to library, we're going to upload a new image. Okay, so you can drop images here, or you can click to submit if you have them saved somewhere on your computer. So this is the file that I just saved. Okay, and we're just going to click open. Files there, it's good. Okay, so I just exit out of this, click done. Okay, so now I have, this is one I did from another session I did last year. This is the one I'm going to use today. Okay, so if we go into our code, okay, and let's say I'm just going to call in setup. So def setup. I'm just going to create our window. And then now we need to grab our image. So we're going to create a character, or a person, right, is equal to load image. Whoops, hit the caps. Just want to make sure I'm spelling that right. Yeah, load image, good. And then here we need to put in the name of the file. So if we go back to here, we can just double check. So that's the name. So I'm just going to control C that, go back to our main and put that in there. Okay. So this code here, this line here is just telling Python, hey, I want you to load an image and save it as a person, as a variable named person. So we've done that in setup. Okay. Now, if we go into, now we can actually put that image onto our screen. So we, in order to do that, we need the image variable or function, sorry. The variable in which our image is stored in, which in this case, it's person. Okay. The X and Y coordinate, we're going to put it straight in the middle. And we're going to make it about 50 big, 50 wide. Okay. Don't forget to call run. We run this code. You guys can see I've printed out our little character. Keep in mind too, if you guys change values like this, like if I were to go like 100, it'll stretch the image. So you can play around with that. Does that make sense to everyone? Is there any questions about that? The slides do explain it well, but I want to show you guys how you would do it. Just a live demonstration, but that's how you can do it. And then to like, if you wanted to, we could do like global person. Oops, no. I believe, let's put this here. Take that out. Right, we can do that. Or, oops. We can also have it follow our cursor. What do I need here? Oh, yeah. Oops. That. Right, I don't have my background functioning, but you guys can see that it follows my cursor. Okay. So that's just like sample code. You guys can reuse that code. You get when the video is uploaded. If you're having trouble to remember, this is a good place to go. Also, the slides are great as well. So let's continue on. So now we're gonna just talk about the our final projects. So these projects are optional, but they are a great source of Ignite points. So if you are looking to finish in the top of the table for the Ignite points, this is the best bang for your buck to do so. Okay, so you can earn up to 250 Ignite points for the project. Okay, and we're marking it based on five categories. Readability, so how easy your code is to read. Efficiency, so maybe making use of functions, making use of logical operators in your check statements. Novelty, so kind of like the story behind it, functionality, and complexity. So you get up to 50 points for each category, sorry. Okay, so the project rubric and each category description can be found in the Ignite Points scoreboard, and you can submit as many projects as you would like till the deadline, which is December 14th. Okay, I'm just going to show you guys the scoreboard real quick. Okay, so I believe it's down here, projects, right? This is the rubric that you guys can use. It's just under, so like if you go to your leaderboard, right, or that link, and then this is the rubric. So this is a good thing to check as you're building your project, right? There's just one question in chat. We can get 250 points over and over again if you submit enough projects that meet all the requirements. Yes. Okay. So you could submit 4 projects, and if they all get 250 points, then you just got yourself 1,000 points. Yes, you guys can submit more than one project. You are able to do that. You can submit as many projects as you guys would like till the deadline, which is December 14th. I believe that's about a week, about just under 2 weeks, guys. So you have just under 2 weeks to submit as many projects as you would like. Okay. My recommendation though would be to make make sure you guys can make one good project, okay? That gets as many points as it can. And then if you have time after, make more, okay? But try and make one really solid project, okay? Just some additional information. So if you guys want to present your project during the gala event, if you guys remember, we have a gala event after the sessions are done. Make sure to have your project ready for presentation at the day of the gala event, which is December 22nd from 6 to 8 p.m. If you guys need help with your project, again, ask us on Discord. I believe you guys are all in Discord. And you guys have been making good use of it too, which is really good to see. You guys can also show off your projects there. Just please maybe don't share your code with everyone. We want to make sure everyone comes up with their own ideas. Yeah. And if you would like your project to get a shout out on our social media pages, let us know. Okay. And we'll take care of the rest. Okay. For submitting your projects, okay, it's the same process as doing the weekly social media challenges. Okay. If you haven't done that, we'll just look at it here quick. So you just need to enter your email, your name. Remember to click final project. Okay. We are the Saturday session. Select your mentor. Okay. You don't need to do this stuff here. This is where you put your link to your final project. Remember, guys, if you guys want to get your link to your project, all you need to do is click save and then share link, copy this link, and that's the link that you submit here. Okay. Very simple. And if there's any other notes you'd like to provide. Okay. Any questions on submission or anything like that? Let me just double check what else we have to go over. Oh, also next week. So today kind of wraps up the end of like any new content that we'll be learning. So next week will be kind of a work session slash kind of we'll have like a fun Kahoot quiz that covers any topics that we covered in these 7 sessions. It's also a great way to get Ignite points. If you're really trying to go for a lot of those, I would highly recommend coming. And the Kahoot quiz is also really great. We'll also have time. The rest of the time will just be used for asking questions, working on your game, okay, and stuff like that, right? It will be mostly a work period, but we will have a nice fun little quiz, okay. Just to remember again for the gala event, okay. It's December 22nd, 6 to 8 p.m. Okay. It's a great time, guys, to celebrate your completion of the sessions. You also get some interaction with industry speakers, so people who have been programming for a large chunk of their lives, and it's actually what they do, right? It's also a great chance to showcase your projects in front of these speakers. Okay. It is optional, but again, we always encourage that you guys come, and the registration link is here. Okay. I believe it's online. I could be wrong. And let me just double check. It should say here. Yeah, through Zoom. So yeah, so the registration link is very simple. Okay. Email, name, if you would like to present your project. Okay. And then just a one more question here. Okay. So we do have one exercise to help you guys a little bit with the concepts we learned today, but there's only one exercise per Bug Busters and Pythonic Lava. So for Bug Busters, we want you guys to create a little character like this, who every time he touches the cactus, he obviously says ouch. I would probably do the same. If you guys want the images that we use, again, I always say that the more like decorative pieces are kind of optional, right? So like it doesn't have to be a cactus and it doesn't have to be a little cowboy, but if you guys want to do it the same, the links for the images are here in the speaker notes. Okay. And it'll also give you the RGB colors for the sand if you want to replicate it the exact way it is here. Yeah. And then for what's it called? For Pythonic lava, um, you're creating a little spaceship flying through space, just trying to dodge the little red, let's call them asteroids, if you will. Follows your cursor. Anytime the spaceship gets hit, damage appears in the middle of your screen. Okay. Again, the speaker notes here in the bottom, the links to all the images, or the images for the spaceship at least is here. Okay. You also might want to use a little bit of random integers in this. You guys can notice that not all of the little asteroids are moving at the same speed. Okay. So these are also good starting points for games, guys. Like some of these have concepts that you might want to implement in your game. Okay. It might provide a little bit of a starting narrative too for you guys' game as well. So we're also going to look at some project inspiration. So these are some that we have seen in the past, I believe on our YouTube as well. We have a video displaying previous projects that are actually completed in this course. So keep an eye out for that. But here's some inspiration. So for example, there's this ball game where you try and launch the ball and hit the green square, right? Or we've seen a lot of the Flappy Bird or Flappy Block variants throughout the years. But really try and be creative, guys. This is your time to shine. This is your time to show us what you know, and kind of also make it your own, right? You don't get a lot of projects like these where you get to really make it your own. So take advantage of that and make something cool. Sky's the limit, guys. Okay. In terms of slides content, that's pretty much it. If we did Flappy Bird with something new added, would it be creative or no? Yeah. I mean, yeah, if you could add a new concept into it. We've seen games with you've seen like little cowboy shooter games too. I've seen a couple of those. Let me just double check the YouTube and make sure that here, let me pull this up over here quick. Let me see if that video is up. We could maybe watch it quickly. There are a lot of videos on here. So it might be up there, guys. It might not be. I haven't checked in a while. But yeah, those are kind of the ideas. If you guys want to run ideas by us, please do in the group chat in the Discord. We'll always give you guys feedback on the kind of things you guys are suggesting. And yeah, that pretty much brings us to the end of today's content. You guys have any questions? We have plenty of time to answer them. For the collision code, are we supposed to reuse the given code or make our own? You could reuse the code. In terms of for the collision stuff, that's kind of all you really need. But yeah, if you want to make it your own, you can. Okay. There's nothing saying that you can't implement your own collision code if you want. Okay. Claire, I'm not sure. Maybe one of the other mentors can clarify for me. I believe you don't get marked for the project if it's handed in late, but I could be wrong. Constantine, to answer your question, yes, you guys do. So you guys will all get a certificate, I believe, by email. If someone wants to quote me on that, please do. But you guys do get a certificate if and only if you guys attended, I believe it was 6 out of the 8 sessions. Okay, so next week's session does count. Okay, so if you have missed 2 sessions already, you need to come next week as well to get that certificate. But that's the only requirement. Doing assignments and exercises are completely optional. Those are more so for your guys' learning and for Ignite points. Okay. The final project is supposed to be a game. Okay. Or can it be code that uses all concepts that we learned in this course? I mean, most of the concepts, like we kind of covered. The idea of the course was to teach you guys basic concepts of Python through like these kind of creative drawings and stuff like that. So the concepts that we learned in this course were kind of geared towards that. So creating a game would kind of be the easiest way to display all of the concepts that we learned in this course. Um, but ideally, we'd like to see a game of some sort, if that answers your question. Uh, I can't remember, Luis. I believe we had someone ask this earlier, and I can't remember what the answer was. Maybe Tony, I don't know if you remember, or if any of the mentors, if you guys remember what the answer to this question was. You can still try and submit it and see, but I don't think you do, to be honest. But guys, that being said too, if you guys have submitted a project late, that's you guys can still attempt the assignments. They're still good assignments to attempt. And the nice thing about each week's assignments is that they build off each other, right? So um they really help solidify your understanding of the concept. So even if you don't get marked for them and you guys have time, I'd still recommend doing them. Okay, because you guys can learn lots from them. Yep, you guys can take it again. If you guys really want to, you guys can take this course again. Um, yeah. If you guys are feeling confident though, I recommend taking the advanced Python because you get to start building more advanced games using Pygame. Okay. And that stuff is really fun. Okay. I'm not sure yet. I haven't seen anything, but we will, if you're in the Discord, we'll post notifications in there. So just keep an eye out in the Discord. I believe that's in the announcements channel. Don't check. Yeah. Yeah. So yeah, if you go into the Discord and if you go into the announcements, you should see um what's it called? Postings of when the next courses are available to sign up. Okay. They might, I believe that they start around March though. That's where they started last year or early this year, I guess. Last semester is around March. Any other questions, guys? We still got about 10 minutes left in the session. Um, if you guys are planning to get started on your project, like now would be a good time to ask questions regarding that as well. Um, the sooner you get started on it, the better. I'm gonna see if I can find it. Guys, we are at basically at the end of this. Oh, it's more so up to you. So it's based on your comfort level. Um, if you did Bug Busters now and you feel like I would recommend doing Pythonic Lava and then doing Flare. Because Pythonic Lava, we give you guys more challenging stuff. It will be the same content, right? But you'll be doing more challenging tasks throughout the sessions. So, I mean, hey, if you're feeling very confident in your Python ability, right? Try Flare, right? If you want more practice, Pythonic Lava would be a um great level to try. Oh shoot, there are end of session questions. Thank you for reminding me. Um, oh my goodness, I can't believe I almost forgot. Um, yeah, we have two end of session questions. So if you guys want to head over to Top Hat, we'll just open those now. Oh, thank you for reminding me. I almost forgot. Um, yeah, the questions are up right now, guys. Or the first question is, if you guys just want to answer that. Okay, and then I'm just gonna make the other question open as well. If you guys just want to answer that one quickly as well, please, that would be much appreciated. After you guys answer that question, though, you guys are free to leave if you guys don't have any questions. If you are leaving, have a great weekend. We hope to hear from you guys in the chat about your guys' projects in the Discord. Sorry. Yeah. If you have any questions too, I can answer them now as well. If not, have a great weekend, guys. No worries, guys. Thank you for coming.